I'm going to find the Laplace transform of f of t, which is equals to 2 if t is greater than or equals to 0, but less than 1 and 0 otherwise. So we are given that function there. For us to find that Laplace transform, I will start by drawing the graph of f of t. So for the graph of f of t, I will draw my horizontal axis, label it a t, and then the vertical axis, label it the f of t, and then put the pointer 0 there, and then the 1, then the 2 on the vertical axis, then label it a 2, and then go on and plot that line there equals to 2. So we are saying is 2 between 0 and 1. So we now have that graph of f of t. The next step now is to try to write our f of t there in terms of the Heaviside function. But in this case, we are seeing that it has a 2 here. So we'd see that it is of the form of 2 multiplied by h of t. So I would plot that graph 2 multiplied by h of t, and I will indicate it by a red line. So I'll plot my horizontal axis, then put the t, then put the 1 there, then go on and put a 0, and then plot the vertical one, then label, then the 2 there. And for the h of t, we are saying it will be equal to 2 whenever t is greater than or equals to 0. So that's the 2h of t there. And then I'll go on and draw the graph of 2 multiplied by h of t minus 1. That's the graph of h of t shifted by 1 unit to the right. So I will represent it by a green line there. So that graph there, the green one there, that's the 2h of t minus 1. I will now go on and label my graphs there. The one on top, I'll call it graph number 1. And the second one below there, I'll call it graph number 2. So what we want there is to obtain graph number 1 from graph number 2. So for us to obtain graph number 1 from graph number 2, we have to make 2 0 in the interval 1 to infinity. The 2 that I'm referring to is this graph 2, the one which is below there. And just because if we do that there in the interval 1 to infinity, the one that I'm indicating by the braces there, if we make it 0 there, then it will be looking like the graph number 1, which is the f of t that we are having. So for us to have a 0 there, what we have to do is we have to subtract the green line from the red line. So in other words, what we'll be saying is we are achieving this by evaluating 2h of t minus 2h of t minus 1. So that is the one that will give us the f of t in graph number 1 there. So what you are saying there is f of t is equals to 2h of t minus 2h of t minus 1. So that's our f of t there in terms of the Heaviside function. And then we go on and take Laplace transforms. So the Laplace transform of f of t is equals to the Laplace transform of 2h of t minus 2h of t minus 1. Then use properties of Laplace transforms, and it will give us the Laplace transform of 2h of t minus the Laplace transform of 2h of t minus 1. Use the properties of Laplace transform again. We can factor out the constants here so that we have 2 multiplied by the Laplace transform of h of t minus 2 times the Laplace transform of h of t minus 1. So that's the Laplace transform of f of t there. And then we go on and look at this function here, h of t. And then go on and consult our table of Laplace transforms so that we get the Laplace transform there. So we see that the highlighted part is of this form here, h of t minus c. So by comparison of the two highlighted functions, we see that our c there is equals to 0. So if c equals to 0, we substitute it here. Then we have the Laplace transform there is exponent of minus 0 times s divided by s. Exponent of 0 gives us a 1. So our Laplace transform simplifies to 1 over s. So that's the Laplace transform of this highlighted function, so that we can rewrite there as 2 multiplied by 1 over s. And then I go on and look at the next one, this one here, h of t minus 1. We see that it is of the form h of t minus c. By comparison of the two highlighted functions, we see that our c there is equals to 1. then go on and substitute c equals to 1 in this function here, so that we have our Laplace transform there is equals to exponent of minus 1 times s over s, and that will simplify to exponent of minus s over s. So that's the Laplace transform of h of t minus 1. Then we put it in our formula here, so that we have minus 2 times exponent of minus s divided by minus s. So that's the Laplace transform that we are having, but we can put these 2's in the numerator there, so that our Laplace transform becomes 2 divided by s minus 2 exponent of minus s divided by s. So that's our Laplace transform of the given f of t.